We'll be talking just briefly on creating an exploded isometric drawing and using the NamedPosition command as a useful tool, and also about construction planes. So what is a construction plane? I'll hide this for a second. This is a representation of what our construction plane is. It determines what our origin point is for our workspace and also the orientations of our workspace. So that will be our x-axis here at the bottom, our y-axis, and our z-axis perpendicular to that plane. So here we have our x-axis in red, y-axis in green, and z as the normal to this plane. And by default, if we head out to our other viewports, Rhino has our construction plane set to the top view. So wherever we have a command, such as creating a rectangle, for example. So I'll type rectangle in the command prompt, enter. Our cursor is sticking to this construction plane. It's adhering to this origin point as the elevation, and whatever I'm drawing will be within this XY plane. And in most cases, that's good, and buildings tend to use this plane because our ground is flat, and this is a flat construction plane. But if you have some object that's a little more complex, for example, so I'll just hide this chair first. Something like this box, which has some cutouts to it. And you want to apply some changes directly onto this face, it might be a little bit difficult to be using this construction plane on top of these areas. So what I can do is I could set my construction plane to a different plane. So our panel here, CPlanes, is everything we need in regards to our C-plane. And just looking at these set with the arrows are like default views that we could apply our construction plane. So right now it's the world top construction plane, and I could set it to world front. And what we'll notice is that now it's changed orientation. Our X and Y have moved, and our Z in effect has moved as well. So Y is now in what was previously the Z direction, but our Z direction is perpendicular or normal to our XY plane. And we can choose different options, and that'll show that our orientations have been altered. And so if I were to apply the same rectangle tool or rectangle command, if I can spell rectangle, then my cursor will be applied to this plane, and instead of what was previously a flat rectangle, it's now vertical in our workspace. And we're using this construction plane to help adhere these commands to it.
Okay, I just, Eric, can you interrupt you? You just
using simple.
So just, I want to reiterate what Eric said, like Eric's explanation in a little bit different way.
Yeah.
So we're modeling in 3D space, but when we are selecting a point, our screens are flat, so it's always a plane. We have no means of selecting a point in 3D space. Actually, we don't. In most cases, there are special 3D mouse, like 3D mouse devices, but they're still quite rare and they are quite difficult to use. Actually, you need to learn how to use them. So we always choose a dot in 2D space. So, and basically that's what and how you choose this 2D space in 3D world of Rhino. Right? And basically construction plane is the plane where we're choosing dots. So you choose a plane surface which is your working surface for a particular time when you are working with your model. You are interested in placing, in selecting dots in this, on this plane. It can be X, Y, like your world coordinate, X, Y plane, as like Eric started with. And then you can choose one of like X, Z, Z, Y, or you can choose any plane specifying like particular dots or using other methods. Okay, sorry, Eric.
Yep, no worries. And so when it comes to more complicated angles such as this, then we can use our command over here to set our C-plane to a specific object or a specific surface. And if, for example, some case you just don't have the C-plane panel, you could simply type the command C-plane, and that should give you the options that you would see here as icons. And so I want to select the surface C-plane. So I'll choose this little corner, and here it gives us now the option to enter our origin and adjust our orientations of where the X and the Y planes are. And now I have my new work plane on this, this angle. And I'll do again that same command here with our bottom corner. Select surface to orient C-plane to. Here we go. Here's our origin, and I want my X and Y to be something like that. I don't know. And you'll see that it has now adhered to the surface because we have faintly our construction plane graphic on top. All right, so now if I were to create a rectangle, my rectangle is going to adjoin to that plane and lie flat on this surface, which if you were to do that same command, applying a rectangle to the surface, when the C-plane is in its default position where X, Y is flat to this bottom portion of the box, then you'd have to do several commands in order to rotate and then move to the surface, the rectangle. So that's an easy way to
and for example, if Eric wants to perform a Boolean operation, for example, making a deep like some like cut in his object, so he should draw a rectangle on this construction plane and then extrude it inside and then perform a Boolean operation. And that's what, like, that's the benefit of using construction planes.
Yeah. And what's great about construction planes is that they have like a little bit of an organizational panel with it. So now let's move to our chair, which you can download, and let's start applying construction planes where we see fit. And there are a few angles where I feel like we can apply that to. So here I'll do set plane to object, just to show you what that looks like. And it automatically sees which area you clicked on with your cursor and applies that to that surface. So I now have my C-plane on this surface of the leg. And if I were to type named C-plane, this is the dialog I was talking about, how we can organize our C-planes or construction planes. I have this new one, so I'll simply click save. Let's call this right leg. And now if I were to switch between different construction planes, I'll have this already saved for easy access to work onto. And so now I'd ask you guys to continue applying different construction planes to the rest of the model wherever there's like a weird angle that would be difficult to work with otherwise. So again, I'll type CPlane, I'll do surface, and join to this left leg now, and I could save that left leg, and that'll be in our little catalog, so we can quick select it when we're modeling. Lastly, I'll do another one. This time I'll type object, and now we have a new C-plane adjoining to the backrest. Okay. There are a few other options. We can change the elevation. So with our world top toggled on, we can simply move up and down where the origin of this work plane is. So if I wanted to work specifically with the seat top, I can switch the elevation of it, type C-plane, choose elevation, and we can move it up and down in the Z direction. So with my O snaps on, I'll select this top portion of the seat, and we could call that seat, simply. And this makes modeling a lot quicker now, knowing that you can have the default cursor to create your commands adjoined to whatever C-planes that you've applied to the object or building sections that you've been working on. So here I could now create my curved outlines without having to worry about creating it on a different construction plane, then rotating it, then moving it, and then not knowing if it's exactly parallel to the surface. So that's the benefits of C-planes. And there we could extrude it and do Boolean command, as Leo had mentioned, and we'll know that it is perpendicular to the thickness of this chair leg.
Eric, can I ask you a question?
Sure.
Like, actually, I have a couple. First question is, can you change your construction plane during, like, for example, you're creating a polyline. Can you change your construction plane while you're creating the polyline?
I see what you mean. So like in the middle of a command.
Yes, yes.
Okay, we can try that out. I'm not so sure. So oops. Just make sure it's not, selecting any other object like this. So I'm in the middle of a curve command in this left leg C-plane. So if I wanted to change it now to seat, what will that do?
No, it's not working.
So it's still somewhat adjoined to, or it is adjoined to the C-plane that the command was started on. Okay, so to answer your question, no.
Apparently, no, at least not this method. It's okay. At least it's not, we cannot see it. And another question, if, for example, you're creating a block, and this seat can be perfectly a block, will C-planes defined for a block local for this block, or they will be global for the whole model?
It should be global, I believe. So if I were to move this, the C-plane would remain at its seat. And so if I were to make a block, that would also have the same principle. The C-plane is assigned to whatever the object is.
To the surface.
And then it'll remain there. It's not to the object.
It's important. So it's important that actually it's not just, you're not specifying a particular plane, but this plane is linked to the object. No, I see.
We can link a plane to an object. So here I could select the seat and have this command set mobile construction plane. And this will attach to the object. So simply select the origin and then orientations. And I'll have, okay, enter. And now I'll have a plane that if I were to move this, should adhere to it. So there is the construction plane.
But your previous, if you select now, if you select your seat construction plane, it will be at the previous position.
Yeah, we'll go back to this.
Oh, I see. So by default, it's not linked. It's not linked by default. It's
no. So if we want to reapply that mobile construction plane, we'll have to again select the object, attach, and then set the origin and orientations of them. And then now we can work with live updates, basically.
Okay, and you can also save it. You can also save it, and it will be like save it as a construction plane, right? On the list.
This one, I believe not.
Can we try?
Decide. Okay, mobile construction.
And now if you move it.
So let's move this to the normal. And so the mobile construction plane is still applied, but it's set to where where the object was placed previously. And so when we save that, it saved that in the 3D space, not to the actual object.
I see.
So you can't save a mobile construction plane to the object. You're saving the location of it and wherever position that it was placed.
So basically, we cannot come back to a mobile construction plane. It will be mobile only while it is active.
Yes, exactly. And then that's where you have the options to attach and detach. So it's always based off if it's on or off, basically. All right, so that's basically the gist of construction planes, and we'll now move on to an exploded isometric. So an isometric drawing, if I type isometric, we'll have 4 different views. It basically projects this 3D representation of the object or the drawing, and it'll be, I think, 30 degrees to the I guess baseline. So imagine there's a baseline here, and then your object is 30 degrees and 30 degrees from that baseline. And unlike a perspective, this drawing will be accurate in terms of dimensions. So your dimension here will be the same as if it were in a plan or a section. And so it's a useful drawing to understand the object or building in a 3D space while still retaining the dimensions and measurements. So in this case, I want to have both an isometric drawing that's in its constructed phase, but also when it's exploded. And oftentimes when you explode it, you're ruining the model that you worked so hard on and had all these details, and it fits perfectly. So we have this command called NamedPosition, and it saves the position of your elements and allows you to toggle between them as long as they aren't, I guess, deleted or modified. So I could save this position where it's in already constructed. Let's call this constructed isometric. And so we'll select the objects, enter, and that's in a saved state now. What I can do is continue to explode the drawing. So moving our objects up. Oops, what happened? Isometric. Let's go back to this southeast orientation. And let's say these legs were moved out or forward. So we can see kind of like the parts of this. And we'll save this state. Call that exploded isometric. Select the objects, and now we have this new save state. And when we toggle between the two, oh, why does it keep doing that? Yeah, when we toggle between the two, it'll automatically place it to that state that we saved it. So, it's annoying. Okay, we'll probably have to create it again. So I'll delete these two. Okay, select the objects, save this as constructed isometric, or rather, exploded isometric. And then try to Frankenstein this back together. Save that, for example. Okay, doesn't really matter. But now this is our constructed isometric. All right, and now we could shift between the two states. So it's now constructed and exploded isometric without having to worry about like bringing back to that same position that I was struggling with, right? So these give you the two states, and you have the freedom to, I guess, like create diagrams and change around different elements with knowing that you can always revert to the original state. And so these are great for diagrams where something is kinetic, for example, or you want to show a space that's closed or open, and or an isometric that's exploded to reveal more of the elements within. So I would suggest creating different name positions for those states so that it's a quick process to switch between the two, and then you wouldn't have to actually create a new file or a new copy, which I would do back in the day. So there is that. And one thing is, if you were to delete an object, then that object is permanently deleted in the state. So even though you saved it with its two legs here, it's gone. It's gone. And also some modifications aren't the best, so they will still apply to that one state when it's not saved, but then once you go back, that modification is removed. So just keep those in mind. If you ever make a change and a deletion, you'll have to resave the state. Okay, so we'll take this and do a few times. Go back to exploded position, and let's head over to our isometric view. I think northeast is what we want, yeah. And if we want to bring it over to another software like Illustrator so that we could adjust the line weights and make a pretty diagram. This thing is so finicky today. Okay, and what we could do is select these and type the make 2D command. So it's going to take this 3D projection and create a 2D drawing from it. And there will be several options that we could choose from. We could select the view that we are currently in, or we can select the C-plane. So whatever the C-plane is currently set to, right now it's, I think at the default, it will take the items that are on the C-plane and create a 2D drawing from that. So that would be our little legs at the floor, and some other options, including getting all the other orthogonal views, like your top, your left and right views. But for our sake, we want to keep the 3D isometric. And a few other options that are useful are having the scene silhouette lines. So instead of having to manually draw out the border, we can select that and include it into the make 2D command. And when we select OK, we're creating new layers that are holding these curves. And this will be visible in the top view. So here we have our exploded isometric drawing separated into proper layers, and you'll see that is true with the colors that we've selected for each layer. And now what we could do is select these lines and export them into an Illustrator file. And as you've seen, I've already saved that. Some options will come up. You'll want to most likely preserve that model scale unless this is an isometric drawing that doesn't really require accurate measurements. So if not, then you can just take a snapshot. But then if you want to keep the measurements, then preserve the model scale, and whatever you're taking this dimension or measurement, and it'll become 1 millimeter in the workspace in Illustrator. So if this is 100 millimeters from the bottom of the leg to the top, then that will be 1 millimeter in your workspace in Illustrator. Okay, and so we can accept that and head over to our Illustrator software and open that up, and I'll just show you how that becomes exported and then summarize the rest of this tutorial. Or I could do that now. So what we learned today was construction planes can help aid the process of modeling, especially when you have unique angles that aren't orthogonal to the default work plane in Rhino. And so you could set these work planes to your angles and even create a mobile construction plane that adheres to a surface or an object even when it's moved or modified. And we've learned the named CPlane command, which you can organize many different construction planes that you've created and toggle between them easily. We also learned the NamedPosition command, where we can save different states of our model and kind of move around these objects so that they can, you can create diagrams, for example, and not have to worry about changing the original state of what you've created. It'll always come back to it. Okay, and let's open this up. Here we are, exploded axonometric. Because I made it 100 millimeters, which is a bit small, you can see that in the workspace it's very, very tiny. And here in our layers panel, they should be, yes, they should be organized into the respective layers that Make2D had created. So we have our scene silhouette curves, which were the outlines, and then the remaining curves, which are, oops, there we go. So with our scene silhouette, we could select those and change like their stroke properties to make them larger, and from their work in Illustrator.